Hello and welcome to student. Today's lectures we are going to discuss the topic electrochemistry. In these topics we have see the various terms they are used for the determination of electrical conductance. But you know that in electrolysis the current can pass through an electrolyte solution. Fine. The systems can use the two types of conductors to passing the current, the electronic and electrolytic conductors. The metal wires that joins and supply the electrodes, the electronic conductors and electrolyte solution is the electrolytic conductors. And therefore, for electronic conductors, main source are used as the electrons for the passage of current, and electrolytic conductors mainly used for the passage of currents by the solution in the ions. And there will be the two types of current carriers, like they deals with electrolyte solution with ions. The carriage effects of passage the current in the solutions. Now next points we are going to discuss is here the conductivity. You know that conductivity it means the conductivity of a solution of an electrolyte. It can be measured by using the terms can be defined as the resistance. The resistance of solution of an electrolyte can be measured by placing between the two electrodes and using the principal Fiction-Bridge circuit. The conductivity of a solution of an electrolyte can be measured in terms of conductance. And therefore, you can see the define the conductance, which is designated as small k. So, conductance of a solution can be defined as it is a reciprocal of the resistance and has unit is Siemens. It is denoted by capital S, and conductance can be presented as small k. But the conductance of various solution can depend on the volume of solution that the two electrodes will enclose between them for the measurement of the conductance. The distance between the two electrodes and area of cross section between the two electrodes will depend on the geometry of conductivity cell used for measurement of the conductance. The system can be measured of the conductance of solution is known as the conductivity cell. This cell can consist of a glass tube in which the two electrodes can fit as like the platinized platinum electrodes. These electrodes can fit such that the volume of the solution can enclose between them is about 1 cm cube. Hence, for comparison of conductance of two solutions, the conductance of a solution per unit volume is defined as it is known as specific conductance of solution. It has units is Siemens per meter, and it is represented by the K0. You know that relation between the conductance and specific conductance? Now here we have the relation between the conductance and specific conductance, but also depend on geometry of the conductivity cell, which is obtained on the basis of their relation between the resistance and a conductors of its length, area of cross section. That is, these relations are, you know that resistance, that is, sorry, resistance R is equal to the sigma into L upon A, and therefore this K is the conductance of the solution is equal to in bracket 1 upon sigma into second bracket capital A upon L, and therefore specific conductance of solutions, that is capital K is equal to, sorry, this small k is equal to K0 into in bracket A upon L, and therefore the specific conductance of the solutions is equal to, by modifying those equation we get K0 is equal to this K into L upon A, and therefore specific conductance is equal to the conductance of the solution into cell constant. Next points we are going to discuss the equivalent conductance. Equivalent conductance, it is defined as the conductance offered by that volume of the solution which contains one equivalent of the electrolyte. It means that the conductance offered by solution which contains the one equivalent weight of electrolyte is called the equivalent conductance. Now we have see molar conductance, same definitions which are equal to equivalent conductors. Only difference is that this the solution which contains 1 mole of electrolyte in place of 1 equivalent electrolyte. So both equivalent conductance and molar conductance, they will show same define. Only difference is that the inequivalent conductance contain 1 equivalent of electrolyte, and in molar conductance they contain 1 mole of electrolyte. Both terms like equivalent and molar conductance can be related to the specific conductance of the solutions, and therefore they can measure the conductance offered by unit volume of the solutions. Equivalent and molar conductance will be the product of conductance per unit volume and the volume containing the one equivalent or 1 mole of the electrolytes, and therefore by the formula equivalent conductance is equal to specific conductance into volume containing one equivalent of the electrolyte, and molar conductance is equal to specific conductance of the solution into volume containing 1 mole of electrolyte. That is the formula of equivalent conductance. And the molar conductance we can calculate by using knowing the values of the specific conductance of the solutions or the volume containing the one equivalent of the electrolyte. So by knowing the values of such specific conductance of the solution, we can find out the equivalent conductance and molar conductance. But you know that these the equivalent conductance, like the equivalent conductance or the molar conductance of solution, can be represented by this lambda, and therefore this capital lambda is equal to the K0 upon C. We know that K0 is the conductance. Which conductance? It is the conductance of the solutions, and therefore C is the concentration. So unit of lambda is equal to if Siemens per meter per mole or equivalent per meter cube. Correct? Sorry. So these equivalent conductors or the molar conductors of solution can be represented by the lambda, and therefore lambda is equal to K0 upon C. K0 is the specific conductance, C is the concentration. But unit of this molar conductance or equivalent conductance are like the Siemens per meter mole per meter, per mole, Siemens per meter per mole, or equivalent per meter cube. Unit of molar conductance is Siemens meter square per equivalent, and equivalent conductance is the Siemens meter square per equivalent. So these are very important, which are asked to the various exams, as like the unit of molar conductance is dash dash, or unit of equivalent conductance is like dash dash. Now we have see the if this small c is the concentration of the electrolyte in either equivalent per meter cube or moles per meter cube, then volume contains one equivalent or 1 mole of the electrolyte will be 1 upon C. It means per concentration. But also you know that the unit of various conductors, as like the conductors can be shows unit Siemens, capital S. Specific conductance like a K0 is equal to Siemens per meter. Equivalent conductance unit is Siemens meter square per equivalent. Molar conductance is unit is Siemens meter square per mole, and cell constant unit is per meter, but practically use is per centimeter. Right? Now we have see the variation of equivalent conductance and molar conductance with the concentrations. Firstly, you know that the specific conductance of solutions, it means the conductance offered per unit volume. But such a conductance will depend on the number of ions present in the unit volume of the solutions, and therefore such a conductance, it means specific conductance, they will be decreases in the concentration of the electrolyte. It means decrease the specific conductance, it means decrease the concentration of electrolyte. Therefore specific conductance is directly proportional to the concentration of the electrolyte. and therefore specific conductance of the solution decreases with the decrease the concentration of electrolyte. Next points which are very important to us. On the other hand, the concentration decreases, the volume that contains 1 mole of or 1 equivalent of the electrolyte increases, right? Concentration decreases, it means the volume that contains 1 mole or 1 equivalent of the electrolyte increases, and therefore increase the volume is more than decrease the specific conductance of the solutions, and therefore the equivalent conductance and molar conductance increases with decrease the concentration of the electrolyte. This is very important point. Next point, limiting molar conductance or the equivalent conductance, which is designated as lambda 0. This limitation first, the concentration tends to 0, the value can be approached to 10. It means that this term can introduce for the solution of an electrolyte having the molar or equivalent conductance of a solution. The value will be approached as the concentration of the solution tends to 0. And these terms can be defined as the limit of molar or equivalent conductance as the concentration they will tends to approach 0. It means the value of limiting molar conductance can be approached but cannot be attained. It is denoted by lambda 0, and it is important to measure the equivalent conductance or specific conductance of the solution. For example, the weak electrolytes as like the weak acids or weak bases, which is partially dissociated, whereas the strong acid or strong base which are completely dissociated. For example, acetic acid is weak acid which are the partially dissociated as CH3CO minus plus H plus. For example, HCl is strong acid, so it is completely dissociated as the H plus and Cl minus, and hence ion in these weak electrolytes which are few are very small, and hence the specific conductance or equivalent conductance and they are very low, right? Equivalent conductance, specific conductance or the limiting molar conductance, they are very low, right? Right. The weak electrolytes, their ions, they are very small in the solution, therefore conductance, specific conductance and the molar conductance which are very low. For example, the 0.1 molar solutions of weak electrolyte, they shows the molar conductance is 5 into 10 raised to minus 4, but such solutions of the strong electrolyte, they will shows 120 into 10 raised to minus 4. Hence, strong and weak electrolyte can be identified from the behavior of molar conductors with the concentration of electrolyte is a straight line. From these d by Huckel-Onsager equations, like lambda c is equal to lambda 0 minus in bracket capital A plus capital B into lambda 0 into root c. So those equations, that is d by Huckel's on square equations, they are useful for this strong electrolyte solution. Can be seen that the limiting molar conductance of strong electrolyte can be obtained as an intercept from the linear plot. However, for a weak electrolyte, the limiting molar conductance like lambda 0 cannot be obtained from this plot. Thank you.